Hi there! In this video I am going to go through day 7 of Advent of Code 2022, and right before starting I want to say welcome to all the new subscribers because it's been a crazy growth with this series, so thank you so much for subscribing to the channel, following the series. It really gives me a lot of energy, so thanks a lot. And we're getting close to 600 subscribers, so if you haven't, join us click that subscribe button and join us to follow the fun. So today we have something quite interesting. We're starting to get in problems that are a bit more complex, not in terms of really algorithm, but this is kind of a parsing one / data structure. So we have some bash commands, I would say, so cd and ls, and we want to construct a tree of files. So what I'm thinking right away is that I want some kind of a nested JSON that we're going to construct while we parse this, and then we want to have a function that just display this in a neat way like that. So as you can see, we need the name of the directory or file, we need the type, is it a directory or is it a file, and we need the size as well. I don't know if we need the size of the directories, find all the directories with the total size of at most this. Okay, so yeah, here we want, basically we just want to create this JSON tree, and then we go crazy, we maybe display it at first, and then we do this math. That's gonna be interesting, so let's get started. The first thing I do usually is I copy paste this input inside the file I have locally. Here this is my template file that I'm using every day. And what do? We don't need, I think I need to remove this line from the template because I've never used so far. So this is, yep, this is it. So I think we want function which is create parse or create tree. Let's say create tree, and here we have lines. So basically here we want the const tree is equal to create tree lines, and we are going to log this tree at first so that we make sure we have something correct. So const tree, this is going to be like, this is the baseline. We have a function that returns an object that contains the full tree, and what do we want in the tree? We want the name, we want is it a directory, because we have only two types, which is directory and file. So usually when there's only two types, I like to use Boolean, that gives less room for errors. So if this is not a directory, we know it's a file, and we have the size. We need to have the size. Is it called size? Is it called file size? Yeah, size. Let's just use that. I think this is all. So let's do the parsing now. So we're gonna do a for of, I think we're gonna do like some kind of a state machine here. Basically, let directory, and for now it's null, or let current node. We are going to say, actually, we are going to keep this. Yes. So just the first thing is, I don't know really how we do this first directory. I think maybe we hard code the first one, the slash. Is there here the input puzzle? Oh yeah, it starts also with this, so we can hard code the first line and ignore it. Maybe we just do that, you know. So tree is gonna be So how do we do that? We say we just say name, and the name is slash the is directory. Oops, I don't know why I keep having this autocomplete. Is directory we set to true. Oh, I forgot one thing that's important here. We have children. This is a node. Node, this is name, is directory, size, and children. This is all we need. So here, children. This is an empty array, and children is going to be, we don't need children for a file. Yeah, that's going to be that. So, and current node is equal to 3. And this is what we are going to do. So, const line of lines, and here we do the parsing. So we are going to check, we check if this is a command first of all. So if line 0 is equal to $, then we know this is a command. Otherwise, we know this is just output directory output. Yeah, those are the two choices, right? Actually, let's not do that. We're just gonna do that. So let current command, and here this is null. So here basically we're just gonna lines.shift ignore the first command. Or do we need to ignore the first command? Let's not ignore it. Let's just use it actually. So the first command here, we need to do a switch to parse this. So it's always one thing, and it can be space with another thing, and it can be x dot dot or slash. So we're gonna do a nice regular expression that's gonna be so this is special character. So this, then we have slash word plus, which is going to be our command. I would like to make a named capturing group. I'm just going to check that briefly on the web. Okay, so we need to do like that. So this is going to be the command, and then there's a space, and there, oh, here this is actually not always happening. I think I need to do that to let me check as well. A bit of regular expression magic. Yeah, so here is the two things that I'm using. This is to make name a capturing group, and this is to ignore to use the parentheses, but ignore this group. Those are like the two things that I'm using here. So here this is space, and now this is a capturing group, which is here we can say arg, and this is anti-slash, oh wait, this is just anti-slash w plus. I'm not sure if W is the right. We can actually just do dot plus. That's just gonna work because we want to capture the rest of the string. So here we're gonna do that exec on the line const match. Let's just console log match for now, and here we're gonna break just so we get the result for the first line. I want to go slow, you know, because I don't know, it was day 4 or 5, I went super fast and didn't go well, so now we're going to go slow and do the right thing little by little. So we have our group, so match dot groups dot command. This is the command. So we're going to say current command equal this. And I'm going to say if current command is equal to cd, then here we need to do the change directory. So target is matched.groups.arg. If target is equal to slash, actually let's do a switch case, you know. I don't use switch cases a lot, so you know, why not? It's a bit dangerous because you have to use the break, you have to remember everything, but that's gonna be good. So slash is we need to go to the root of the tree. So we say current node is equal to tree. Basically, we navigate to this tree here. Then if the case is the dot, oh, so the tree needs to have a reference to the parent. So we say current node is equal current node dot parent. That's the way to go up one level inside our tree. And there is a default case here. The default case is x, and we move one level. So that's good. There is no recursivity. We just go one level down. So we need to find this directory within the current directory. So current node is equal current node dot children dot find folder. We need to find folder dot is directory, and folder dot name is equal to target. That should be it. That should be how we navigate. So here we say console log moved to folder target. Oh, can actually say console log current folder, and we say current node.name. But we can navigate, but we haven't created the tree. Now we need to handle the command ls. If current command is equal to ls. Actually, we don't really. Let me check what is ls. ls has no argument, so we don't care about the ls command. Here, this is a command. Otherwise, this is for now it's a file from ls. Command. I'm saying for now because maybe in the future we add more commands, and for now we know this is actually we can say if current command is equal to ls, then we know here for sure. Else here new throw new error unknown state. Let's do that so that we are really clear when there is something unsupported by our code. I really love throwing exceptions because then if by mistake you land on a edge case that you hadn't planned, it's very clear then that you're not where you're supposed to be. Okay, so we need to parse that. And for that, you know what? I love regular expressions. And we are going to use again a capturing group size, and it's going to be just an integer that is repeated. Then there is a space, and there is the rest of the line is a file. So we can do name, and this is just dot plus. And here we exec this on the current line. It's called line const match. And here, what do? We need to create a new state. Let me disable my notification on the phone. Okay, we need to create a new state. So const node. What is the node? The node is name. It's match dot groups. Is it group or groups? Groups dot name. Size is. Oh, do we know if this is a directory or not? Oh, there are actually two options here. Haha. So here we say file match. If file match, then we can do that. Const dir match, and we're gonna do that right after. Actually, let's write this regular expression here. So it starts with the word actually dir, and then there's a space, and then there is the name, which is just we take the full rest of the line. If dir match node equals something. Let's focus on finishing that. Here this is match.groups.size. And what do we need? What else do we we know it's a file. So here is directory false, and here we know this is a directory. So if this is a directory, we need children to be an empty array. Let's do that as well. Name, it's match.groups.name. Okay, I think it starts to be quite big for one function. I would love to split that, but to make that a bit cleaner in terms of code quality. But I just want to focus, and we need to go to the end here. Like we can't refactor because we don't have an intermediate result. So here we have a node, but we need to push that node. Here we need to say parent is equal. This is the current folder, so this is current node, and we say current node.children.push node. Okay, so here as you can see we have a looped data structure. That will be a problem when we want to display the JSON, but you know what? That's fine for now. So here we're going to do the same here. I think we should be somewhat good. So here if I display, yeah, there are some issues. Of course there are some issues because I've written far too much code. So it would have been wiser to split that in smaller chunks and kind of unit test that, but you know what? We're going all in. I've started this way, I'm just going all in. So I've written so much and now I need to debug. So here I'd like to console log dir match, and we console log file match. So the danger, okay, no, dir, and here this is size. Okay, so the good thing is that these two regular expressions are can't overlap, because it's this one starts with, oh wait, we need to make it start here with I forgot how we do that. Start. Oh no, the regular expression to the start of. I'm gonna pause for a second and check that. Up. Okay, so this is the way to say the regular expression should start at the beginning of the line and it should end here. Let's use that everywhere. Here this is the start of the line, and here this is the end of the line, because we want to match the full string. Let's try that again. That wasn't the issue. So here we are displaying dir match, it's dir A, and there's a name, dir A, group's name. That looks correct. Okay, groups is undefined. Oh, because this is not match, my bad. This is dir match here. And here this is not match, this is file match. This is a typical kind of problems. You rename a variable, you forget to make it right. So here we have another issue, which is, the problem is that I'm displaying so many things at the moment. I need to have a bit of clarity, so we're gonna remove these matches because I think we are doing the right thing now. We have current folder. Okay, where am I at? cd dot. Oh, am I current node dot parent? Here we're gonna say console log go to parent and current node, just to see. Basically, we're testing several things here. Go to parent, and here there is no parent node here. The current node should have a dot parent, and it doesn't have that. Okay, so here we added the parent to the file nodes, but we didn't add the parent to the directory node, and this is where this is the most important to have. Okay, so we have the right stuff now. It's not breaking at all, which is good. Let's see a bit more what's happening. So this is the full tree here. We have the tree A, B, C, D. So we would need to display the full thing. So now I think I'm just gonna make a nice function to display the result, because print tree, because that's gonna be super helpful if we need to do more things on the tree. So we're gonna say let depth is equal to 0. We do, oh, actually here we need to do depth equals 0, because this is gonna be a recursive function. Hey, we love those. We're gonna say, so how do? We display we display spaces several times, repeat depth times 2. What am I doing here? I want to display it exactly like that. So here there are 2 spaces. That's what we have. Let's make it a nice string that we can do stuff like that. Here we need the node. So here actually instead of tree we say node. This is the current node. This is not the name. And then in parentheses you say if node.is directory, we say dir, otherwise we say file. Dir, otherwise we say file, and we need to put, haha, this is funny. We need to put size equal, and then node.size. And then if node.is directory, we for of no child of node.children. What do we need to do? We need to say print tree child and then depth plus 2. And that should be good. So here, instead of doing a console log here, let's remove the console log just to see if we have some, we still have some console log. Let's remove those. Okay. Yeah, we remove those and instead we print tree, the tree. Let's see what's happening. Okay, let's remove this debug as well. Too many debugging is confusing. Okay, it looks like we have exactly, oh wait, there are far too many spaces here. Oh yeah, I know. Print tree, here I do +2, it's just +1. Okay, now we have exactly what we want. Beautiful. You know what, I'm really enjoying like doing this where we go step by step and we do the right thing. So we know we have the right data, we know we are able to traverse the tree correctly. Now we need to actually do the param. So I'm gonna read that again. Okay, so we need to traverse the directory, get the size of each directory, and then we can filter them. So I think we're just gonna do one function. Get actually we're not gonna we have to create a function because this is a recursive thing that we're doing here. So function get size of a node. We say if this is not a directory, then we return node.size. Otherwise, we have to do the sum of all the subnodes. So here we return node.children.map child. We need to do get size of child. So basically in the recursion you always need to have the thing that stops the recursion, and this is the leaf nodes. And here basically we get the size of the child, and we just have to sum a plus b. So this is in JavaScript the way to do a sum for an array, and it's good to have 0 here in case there is just one value in the array. Then this is 0 plus the value, and then this works. I think this is it. So here we should be able to find the size of all of any folder. The thing is, it would be good to make a list of the folders with the with the size, because we want to traverse the full tree just once here. Because what we could do is we could go, okay, what is the size of this directory? What is the size of this one? What is the size of this one? But here we just want to go through the full tree, and every time this is a directory, we store the size somewhere. And what do we want in the end? Directory the size of at most. Okay, so basically I'm gonna be doing something funny here. We are going to put a function inside a function so that we can keep the state here. So const directories. Actually, do we care about that? Actually, let's make this right. Let's make this reusable. And here we're gonna say directory callback, and see const directory size equal that, and then return directory size. But here we say directory callback, and we have, what do we send? We send the node.name and directory size. Let's do that. So here, after printing the tree, we say get size tree, and we say directory callback name size. Name size. You'll see this is like if everything works out, this is gonna be fun. No, this is not working. Oh yeah, because this, we need to pass this directory callback to the children here. Directory callback, yes. Okay, so now we have, oh, not good. You see, like we have a very long string. That means we are we are concatenating some strings instead of parsing them. So here in our parsing, when we have the size here, I want to do a parse int to make sure we have numbers. Okay, that looks much better. Let's see if we have the correct data. Yeah, it looks like this is the correct data. So yeah, basically we're just going through the full tree and parsing and outputting the folders with the full size. And now we need the list of folders that have a total size of at most 100,000. So, and we need to sum everything. So we say const sum small folders. We start at 0, and here we say if size dot size is below 100,000, then sum small folders plus equal size. I believe we need to make this not a constant because we are changing it here, and here we can say console log get size, console log sum small folders. Let's see. I think we went really slowly, so I think I'm pretty sure we are getting the right data. That's good. Now we just need a little bit of cleanup here and here. Let's remove that. Now we just have one piece of data. Let's take the full input here, and because I think we made quite a lot of small optimization, yeah, this is super fast to compute, so I love it. Really happy about the result. Let's see, is this correct? This little happy dance, because we have our first gold star of the day, and that was a complex one. I mean, not so, it was like, yeah, just like a recursion, good old recursion. Let's go to part 2, I'm gonna read that. Okay, I think this should be quite simple now. We have several values, so we're just gonna copy paste those. Actually, let me just go back to the, we go back to the small input. One thing I wanted to change as well here, we're gonna say const threshold size, and we're gonna use this because I don't like to have like magic numbers in the middle of the code. So this is going to be it. Here we can, we're just going to copy paste that in part 2, and we're going to make some small changes, and that's just going to be working all right. So here this is total disk space. This is this value, and we have this value, which is required space. Okay, we have this. Here we don't need, what do we need here? So here we're going to say const used space get size. So we're going to be parsing the tree twice here, but I think that's fine, you know. And here I want to just do one small change here. The default for this variable is a no up function, just so we can use the function get size tree like that, and it works fine. So this gives us the full size. So let's display first of all total disk space, required space, and used space. I put square brackets, curly brackets around it, so we can see. Yeah, actually, let's comment that all. Okay, so here we need to say const. What do we need? We need minimum folder size. The minimum folder size is equal to we need, I just need to do some computations here and I'm like a bit lost. So we have the total disk space, we have the required space. So basically this is total minus required. This is oh no, let's do total minus used. This is const available space. This is total minus used. And we need to have, so we know for sure we need to remove one folder. So we can remove the case, the edge case when there is enough space available. This is, we don't care about that edge case. Let's, you know what, if available space is above required space, throw new error, there is already enough space. Let's see, we just remove this edge case from our head, because otherwise I keep thinking about all the edge cases. That's not good. So now we know that we need to remove minimum folder size, which is what we need to remove. This is this one. Yeah, this one, required space minus available space. Is that it? I'm writing like complex JSON code, and then we have to do a subtraction, and I'm like, what's happening here? Let me think for a second. Actually, I didn't change a thing. I think we have the right thing here. We have the required space minus what's available, and this gives us what we need to clean up. So that's good. Should we check here? Actually, you can check. Minimum for the size. This gives us 8 megabytes. 8 megabytes. That's correct. So now we can go through the tree. So we already went through the tree once, and here we're going through the tree a second time, but I think that's fine, you know. So here we're going to say const candidates, and here we're going to say if size is above or equal minimum folder size, then candidates that push, we can push the full node, right? We don't have the node here, we have just name and size. Oh, we should have returned the node of name. Yeah, that's fine. You know what? We just put name and size, and that's fine. We push that into the array of candidate node, candidate folders. So you have D and slash that are good candidate. This is exactly what we need here. And here we're gonna say we're gonna sort the array A and B. We need to sort that from smaller to bigger. So we're gonna say A dot size minus B dot size. I think this is not gonna change anything. Oh wait, why do I have two parentheses here? Yeah, this is not gonna change anything because it was already sorted, and we can basically log just the biggest size. Find the smallest directory that if deleted would free up enough space on the file system to run the update. So we have this is candidate of 0. This is the right. This is our answer. What do we need? What is the total size of that directory? So we just need candidate 0.size. I can remove this, clean up things. We don't need to print the tree here. So basically the print tree function was useless. Let's see here, 24 megabyte, that's correct. So we can go and get the full input here. I think we are, oh wow, that's a big value. Let's see. Yes, that's good. So yeah, thank you very much for following this series. If you haven't, drop a like and subscribe as well, so that you can follow the next days. Yeah, today was really all about recursion. I hope you enjoyed. The code will be on GitHub, so don't hesitate to check, because that was a bit big. Oh, I'm gonna remove that. Okay, I think we are all right. Thank you for watching. See you tomorrow for the next one. Bye bye.